Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to talk about keeping your test data small and targeted, and how that'll help improve your experience working with tests. Tests are important, and tests generally need test data in order to work. But how exactly do you make good test data? I'd say that generally, test data should be as small and precise as possible, while still being big enough to trigger whatever error, edge case, or flow you want it to trigger. But what exactly does that mean in practice? I'd suggest that when you are generating any test data, see if there's any part of it that you can remove without impacting how the test would work. For example, if you've got a test database with 10,000 rows, but all of your tests only care about 10 rows, what are all of those other rows doing? Are they adding any value? It's possible they are. Maybe they're helping with certain size conditions and running on a larger database. But if there aren't tests like that, and these aren't adding any value, then all they're doing is slowing down your test because it needs to create and interact with a huge amount of data it doesn't need to. And if someone else has to look at your test data, they'll have to figure out for themselves if these other rows mean anything or not. Let's look at a couple of examples today to see where we could remove unnecessary test data. And if you stick around to the last example, I'll talk about how I cleaned up some test data from a personal program and dropped my test suite runtime from 70 seconds to 4. Yeah, it's pretty great. Let's jump to example 1. All right, so we've got a little function here, SQL query to find clients. That'll take in a list of client IDs and return an SQL query string. That'll search a table and return all the clients that match. So before looking at the test, let's think about what we should be testing. We've just got one input to think about, and there are basically 3 categories the input can fall into. We could get an empty list of client IDs, we could get a list with one client ID, or a list with more than one ID. Generally speaking, for this function, I don't think we'd see much of a difference if it was a list of 2 or 5 client IDs. This code, I think, is going to work sort of the same way. So this probably means that we just need 3 test cases: an empty test, a list with one item, and a list with multiple items. So let's look at our tests now. So first off, we've got test no clients. That's handling that first case. Straightforward. Might be worth returning something other than none here. Maybe an exception or an empty string. But at least for the purposes of us here, I think none is fine. And now for the second case, test one client. We're testing our second case. Straightforward. Makes sense to me. And now we've got test many clients, which is our third case, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has 11 client IDs, which kind of feels like a lot. It means this line is long, and this line here of what our expected query should look like is also long. But are these extra values adding anything? Not really. As I mentioned when we look at the code, the only thing the multiple elements is triggering is that this map and this join sort of handle them correctly. But as long as we have 3 elements, it should be testing it the same as if we had more. So I'd actually remove everything but the first 3 elements. I would just take that out, and then take that out. And if we run it, our tests still pass, and this is a little easier to read, and it's still hitting the conditions that I think we want to. Now, one reason we might want to have something like this with with more client IDs is if we want to test some sort of upper bound condition or something and ensure we're working correctly with that. Maybe we don't want the query string to be more than 256 characters. Then it could make sense to have a test with a large number of client IDs. But we don't do that here. We just return the string, so having the longer list doesn't really make sense. All right, let's go look at example 2. For example 2, we've got a database class called viewDatabase. It takes in adding views, where it takes a video titles and view counts and adds them to an internal map. And then we can give a video title fragment, and it will return the sum of the views for all the videos that match that title fragment. So similar to last time, let's sort of pause first and think about what we should be testing here. So sort of the main output is through this num views for matching videos. Add views seems to be more setup, so let's focus on this part. And I can kind of see 4 different flows. We want to test that when the title is an exact match, it returns that, just the views of that one video. I'd want to test that if the fragment matches every video we know about, it returns all of them together. If it matches just a subset, it just returns the subset. And if the fragment doesn't match anything, it should return 0. So that seems pretty simple. So let's go down and look at the tests now. So the first test handles the first and last cases I described. We have 2 titles, and they both make sure they start at 0. We increment one title, we make sure it goes up, and the other one doesn't. That's how our flow is tested. Now, the test that the other title still returns 0, that could be its own test, but it doesn't feel as helpful to me if you're not adding some value of something else to the database. So I think it kind of is fine to put that in this one with the other one. Okay, so in the next one, we've got where multiple matches. So we get our fragment, we make sure that it gets 0. Then we add 100 videos with 10 views each that contain that fragment. And then we add 100 videos with 10 views each that don't have that fragment. And then we make sure that the view count is right. It should be 1,000. And then we go to one where we test all of the matches. And we've got similar pattern to the last one. We have a fragment, make sure it's 0, add 100 videos of 10 views each, make sure it's 1,000. Okay, now why was 100 picked? I mean, it's a nice round number, but why 100 here? Why not 50 or 200? If we look at the code, it doesn't really seem to be a good reason. Basically, all that we're testing here is that when there's more than one video that hits or doesn't hit the condition, things work as expected. So I'd say we could probably change these 100s to different numbers. So first, let's make sure the tests pass. They do. And now, if I just change these to 3, and we'd only get 30 views total now. Change that to 3, 30. Our tests still pass, and we're not creating as much data. This seems better to me. It's a little smaller, easy to understand, and I don't think we were gaining anything by trying really large values here. Maybe if things had been different, there might have been a case for that, but with the code here, I think it just added complexity for no good gain. Okay, let's go on to our last example. This example is a bit tricky to show because it involved binary data instead of human-readable test data. But this is the screenshot from my pull request. This is for a podcast app I've been working on for a few years. I'd built up a collection of test data files, generally by just taking actual podcast files that had the values I needed. This had a cost though. I had fairly large test files, and my full test suite took 70 seconds to run, which is long enough that I didn't like running it often, because it would just take me out of the flow. I'd still run it for every commit and things, but I would kind of only run it when, okay, it's the end, it's time to run it now. So I've been thinking of trying to put this project up on GitHub, not because I think anyone needs it, but because then I think it might be easier to walk through code examples and things like this if people can look at all of the code if they would like. So in thinking about that, I realized that I should probably then make the test data I'd made instead of podcasts I'd copied, which maybe weren't meant to be used as public test data. So I thought about what length audio files I actually would need. Some of these files that I was using were 10 minutes long or more, which isn't that long for a podcast, but did my test data need to be that long? I thought about it, and I figured if my test files were 10 seconds long, that would be good enough for me. Most of my tests are around tags or file names, or just the fact that it is an audio file and I can convert it to another audio file. Longer files, it's not really a thing that I've had issues with or wanted to be testing. So I created a new set of test files that were just 10 seconds long, and I replaced my longer, older test files. And then I ran my test suite, and it took 4 seconds. Went from 70 seconds to 4 seconds. I knew using smaller data would improve things. I could see how much time it was spending parsing the larger files, but I hadn't really realized it was going to be that much. And as a consequence, I'm running my tests way more frequently now, because it doesn't take me out of the flow. I can make a quick change and just run the whole test suite. It's great. And as you can see here, I greatly decreased the size of my test files. -1, -9 megabytes, -26, -9. I decreased the size by over 40 megabytes. In fact, all of my test files now sum up to less than 2 megabytes. This was huge. And I did all of this without having any decreasing value to my tests. My tests are still good. They're still hitting what I need them to. They just run a lot faster now. So I'd consider this a great win for me. Thanks for going through all of that with me today. Hopefully, when you're interacting with test data in the future, you might see some bits that don't really need to be there, and now you'll feel confident enough to remove them. If you enjoyed this video, please consider hitting the like button below and subscribing. If you have any comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.